imagination.
So what happens when we have a negative underneath the radical?
Well, if it's like an odd, then you can do it, but if it's an even, like a square
this one
root,
here.
Imagination. Use your imagination.
So that is not a real answer. We could put in the I and find an answer, but it doesn't make it real. It's still not a real answer. It's imaginary. And then Jarrett was saying, if this was 3, could I do it then?
Yeah, negative 3.
Right. I can do it if it's an odd. I just can't do it if it's an even. So we have to kind of remember that throughout today's stuff. We'll come back to it. You cannot take the square root of a negative number or a fourth root of the negative number, but you can of a third root. Can't I have that one? Okay, but that we'll come back to that. Today we're going to solve equations with rational exponents. It's the exact same thing that we did last class, only instead of writing the square root or the cube root symbol, it is written as an exponent. So you know this is the same thing as fourth root
2x cubed.
2x in parentheses cubed
Gotta keep it all.
plus 2 equals 10. So those are equivalent. It's just written in a different form. You are more than welcome to change the form and work it out the other way. I'm going to show you how to not change the form and work it out, which I think is easier. But you can choose which method you want to use when you do your homework. So to start it, when it is in rational exponential form, we're going to isolate the term that has the exponent. We're going to isolate that term. So take away your 2. So to cancel out the exponent, so we can get 2x, you have to raise both sides of the equation to a power that makes your exponent equal 1. It's called the inverse, otherwise known as a reciprocal. It's the multiplicative inverse, because when we raise both sides to a power, when we take it to a power, you have to multiply the exponents. Yeah, I'm just going to rewrite it because that got just really messy all of a sudden. Yours probably doesn't look as messy as mine, I'm sure. Probably not. So we're going to raise both sides to the 4/3. Just multiply the exponents to the reciprocal of the original exponent, so that the exponent becomes 2x to the first. All right, that would be 2x to the 12/12. So that would be 2x to the first. Okay. Are you following me? We're just multiplying by the reciprocal of the exponent. Yes.
By the way this is worded, I thought it would like multiply by what? Like shutting.
When you raise power to a power, you multiply the exponent. So we're not adding the exponent. It would have been 1/4 if we're adding, but you have to multiply them, so we got to do the reciprocal. Now, from here, I'm going to do something that we did back in section, I don't know, 5.1 or 5.2. I think it was 5.1. Not that long ago.
Don't recall.
So I'm going to take 8, and I'm going to rewrite 8 as a prime number to an exponent.
2.
2 to the third.
And then you like distribute it.
So then we multiply our exponents. You go straight across when you multiply your exponents. So we get 2x equals 2 to the 12 thirds, which is 2 to the 4, which is 16. So x is 8. Now what do we do? We need to check our answer. Remember, because we squared both sides, so there might be extra answers in there.
Hopefully not.
Hopefully not, but we need to check it. You can check it on your calculator. So I want you to practice plugging in 8 in the original question on the calculator so that you know how to plug it in correctly.
Can't we just put 16?
So I'm going to check it on my calculator too. So I'm going to do parenthesis 2 times 8, close parenthesis, to the 3/4. Oops.
Yeah. This principal doesn't know how to use it.
I do until I press the wrong button. What are you talking about? I taught you. Me? Okay. So after you type it in,
Whoa.
you should hit enter. It should equal 10 if you've done it correctly, because that's what it says in the equation it should equal. If yours did not equal 10, please call me over so I can see what you're typing in wrong. If you have the older calculators, it's a little harder sometimes to type in it. At the beginning, where you have to parentheses. So you said 2, you said times 8, but then you ended that parentheses with that 8, so it's only doing 8 to the 3/4, so it's not doing 2 times 8.
Yeah, because
So
it's
you
exactly
need extra
that.
parentheses or less. If you do your 3/4, it's fine. Anybody else need some help?
I just wanted to call you when you said that, but I forgot to do parentheses.
All right. So we know that this is the answer. Please do something on your paper so that I know you've checked it. So on your paper, I should at least see this. What was it, 3/4? You can, but that's not approved too.
There's a legit check.
Okay, I don't believe that you checked.
I could write saying I checked it, and it's right.
You know how many people do that and then they have the wrong answer? And there's a big old check mark next to it and no proof that they actually checked it.
That would be pretty
And then the
funny.
answer's wrong.
That's not proof, they just wrote the equation.
But at least I know you knew how to check it, even if you still didn't do it. I put an 8 where the X goes.
Ooh.
That's showing that you checked. If you'd like me to require you to show all the steps, we can do that if you want me to really prove it. Stop making things up.
I'm not making
Orange.
up.
All right, next one. We've got x plus 30 quantity, the entire thing to the 1/2 equals x. So
Whoa.
we need to get rid of that 1/2 exponent.
So
It
we
is
square
already
it.
by itself. So let's take both sides to the reciprocal of 1/2. So both sides to the what? 2/1, which is 2. So when you raise both sides to the 2/1, you get x plus 30 equals x squared.
No parentheses.
It's to the first power. So x plus 30, the first power is just x plus 30.
Oh, no, I meant on that derivative.
On that side,
Yeah.
well, x times x is x squared. So I just multiplied it out. Okay, so now, because there's an x squared and an x in the question, we are going to have to set it equal to 0 and solve it that way. Because of that x and that x squared. solve by either factoring
You can factor it.
or quadratic formula.
Factor.
I will factor it. I'm just trying to write quadratic formula, but it wasn't happening over there. So I'm gonna subtract x and subtract 30. And those are not like terms, so we'll write it as 0 equals x squared minus x minus 30. And we'll factor that. I guess and check, so what multiplies together to give us negative 30, but adds to give us negative 1, negative 6, positive 5. If you get this and you already have your answer and checked your answer, you should be trying the next questions by yourself. So from here, I'm going to set each factor equal to 0. And I get 2 answers. But I only know which answers work by checking them.
So it's 6.
6.
Okay. Yelling out the right answer is not helping
Well,
at this
just
moment,
put a-
because I'm still going to go through all the work.
I just put a check next to the 6, so it has to be there.
It must be them.
I did that too.
Okay, so we're checking 6 plus 30 to the 1/2 equals 6. So 36 to the half has to equal 6. You can check it on your calculator. I'm just going to talk you through it. If you take something to the half, that's the exact same thing as square root. And that one does check. This is a good review over everything that's in the chapter. On Friday, we are going to have a chapter 5 test. So this is kind of a good review of everything that was in the chapter so far. All right, then we're going to check negative 5. We're going to do negative 5 plus 30 to the half equals negative 5. So I'm going to get 25 to the half, which is the same thing as the square root of 25. And that does not equal negative 5. So my only answer is x equals 6. So make it obvious to me that you found your answer, like circle it. So when I look at your work, I can figure out what you've done and then what you meant to say.
40-year-old eyes.
It's true.
Happy late
Happy
birthday.
late
Sunday, right?
Yep, yesterday. Thank you. Okay, so there are a few for you to try. I'm gonna walk around with some checks. You guys try them?
Can I have a check?
I don't know. Can you just give yourself checks anyway?
Yeah.
You just had 5 minutes to work on those. So here, we're going to take both sides and raise them to the 3/1 power. That gives me 3x equals negative 27, so x is negative 9. Then you plug it back in. And you hit enter on your calculator and it checks. So that x equals negative 9 is your answer. The second one, I'm going to raise both sides to the 2/1 power. So I'm going to get x plus 6 equals x squared. So when there's an x squared, we have to make it equal to 0. And factor or use quadratic formula. X minus 3, x plus 2. So we get x equals 3 or x equals negative 2. And you go and you check them. For this, oops, I'm on the wrong page. For this one, we do 3 plus 6 to the half equals 3, and that one checks. For the second one, you do negative 2 plus 6 to the 1/2, which equals negative 2, and it doesn't. 3 plus 6 to the 1/2 equals negative 2, and it doesn't. 3 plus 6 to the 1/2 equals negative 2, and it doesn't. 3 plus 6 to the 1/2 equals negative 2, and it doesn't. 3 plus 6 to the 1/2 equals negative 2, and it doesn't. 3 plus 6 to the 1/2 equals negative 2, and it doesn't. 3 plus 6 to the 1/2 equals negative 2, and it doesn't. 3 plus 6 to the 1/2 equals negative 2, and it doesn't. 3 plus 6 to the 1/2 equals negative 2, and it doesn't. 3 plus 6 to the 1/2 equals negative 2, and it doesn't. 3 plus 6 to the 1/2 equals negative 2, and it doesn't. 3 plus 6 to the 1/2 equals negative 2, and it doesn't. 3 plus 6 to the 1/2 equals negative 2, and it doesn't. 3 plus 6 to the So my only answer is x equals 3. And the third one, you gotta you gotta raise both sides to the reciprocal power. So we're gonna do 4 over 3. For some reason, I don't have room to write it. So I would get x plus 2 equals 8 to the 4 over 3. And I'm going to change that 8 to 2 cubed to the 4 over 3. So then we multiply our exponent. 3 times 4 over 3 gives me 2 to the 4. Is 16, so x is 14. We need to check it. You can type that in your calculator and check it. It does work, so x equals 14.
Oh, there we go. I wrong spelled it when I didn't check.
Oh, on the
I got
check.
to the 14, but
Gotcha.
the half number.
Gotcha. Okay. All right, the last section of the notes today, we're going to be solving radicals that have inequalities. So they're not equal signs, they're less thans or greater thans. Inequalities. So I'm going to start out by solving these the way that you think you'd solve them, just the same that we did the equal signs. We're going to divide by 3, and we get square root x minus 1 less than or equal to 4. How do we get rid of the square root? This is the same thing, x minus 1 to the 1/2. Square root and 1/2 power are the same. What am I going to do to both sides to get rid of the square root?
Multiply by
Well, you're going to raise it to a power.
well, yeah, but.
What power is that?
2 over 1.
2 over 1, right. So if you wanted either form, if you prefer radical form, if you prefer exponential form, either form, you're going to raise it to the second power. So we get x minus 1 less than or equal to 16. So x is less than or equal to 17. What this means is x can be any number that is less than 17 or equal to.
17 or x.
I don't know what you mean.
Do we have to check that?
I'm doing that right now. I'm going through that part right now. Okay, so when you get this answer, you get that x is any number that's less than or equal to 17. Somebody give me a number that is definitely
1.
way less than 17.
0.
1.
0?
0 might be easy.
0 might be an easy one.
16.
1 is basically 0 and you times 0. 0 is less than.
Okay, so you can choose 1. I'm going to choose 0.
That's fine.
Look what happens when I plug in 0.
Imagination.
3 square root 0 minus 1 less than or equal to 12. So 3 times the square root of negative 1 is less than or equal to 12. What happens if you take the square root of a negative number?
Imagination.
This is not real. This is not a real answer. This is an imaginary number.
Well, no number.
So
is less than something.
when I give the answer of x is less than or equal to 17, that's actually not enough information for this question. Because it can't be anything less than or equal to 17. There is a restriction that says the square root itself, the stuff underneath it, has to be greater than or equal to 0. You can't take the square root of a negative number. So there is one more step to this.
Greater than 1.
You have to set it's called the radicand radicand, which is just stuff under radical. You just set the stuff under the radical greater than or equal to 0. You have to do that. So there's a second part to this question. So what is the stuff under the radical?
X minus 1.
We do x minus 1, and we do greater than or equal to 0. And we can solve this also.
X greater than 1.
It means I'm only allowed to use numbers that are less than equal to 17, but they also have to be greater than or equal to 1.
Oh no.
I'm going to show you that visually, and then I'm going to write the answer. Actually, I started drawing that number line up there. I'm going to put it down here where you can see the actual answers from my work from before. So we want all the numbers that are less than 17 and greater than or equal to 1. So when I say the word and, has to be both of these. I say the word and, it has to be both of these. You look at my picture, where are both graphs? Where? Between 1 and 17. So we write our answer as x are all the numbers in between 1 and 17. So this is my final answer. This is what you would have to write down. If you need the number line, then you draw the number line. If you get it wrong and you don't have a number line drawn, I'm going to say, why don't you draw a number line? Okay, let's do the next one. What are we going to do first?
Add 4.
We're going to add 4 to both sides. We get 3 radical x less than or equal to 12. Divide by 3. Radical x less than or equal to 4. What do we do now? Square both sides. We get x less than or equal to 16. But we also have to look at the radicand. What's underneath the radical in the original question? Just x. That itself has to be greater than or equal to 0. And I don't have anything to solve for that one. It's just x. So x also has to be greater than or equal to 0. So if you're looking at a number line, 16 has to be less than or equal to 0. X has to be greater than or equal to 0. Where do they overlap? In between. So you do 0 less than or equal to x less than or equal to 16. The next example did not get printed. So you have space to do it at the bottom. It will be up there in just a moment once people are done coming up. But the next example that I'm going to do isn't on your paper. You're going to have to copy the question down. So 2 radical x minus 5 greater than 6. Two radical x minus 5 greater than 6. What are we going to do first? Divide by 2. So I get square root x minus 5 greater than 3. So we square both sides. X minus 5 greater than 9. So x is greater than 14. We also need to look at the radicand. What is the radicand? X minus 5. So we have to say x minus 5 has to be greater than or equal to 0. Otherwise, you can't take the square root of it. So x also has to be greater than or equal to 5. So if we look at a number line, 5, 14. We've got greater than 14, and we've got greater than or equal to 5. Where are they both? They're both greater than, just greater than 14. They are not in between this time. So you kind of got to look at the number line. X is greater than 14 is our final answer. Okay, take a moment, try 11. I will go over it. I will go over 12 or 11B, whatever that is, the other one too. Well, see, it just changes when you draw the dot, if it's a solid dot or an open dot. So I did greater than or equal to every single time for the radicand because it can equal 0. It can equal 0. It just can't be negative. So you always do greater than equal to, regardless of the way the other one is. You got 97. 97? Or am I hearing you wrong?
You got 97 or 97?
97? Oh, yeah. Oh, for the two different answers? Your answers have to be like x is greater than, or x is less than, or...
I didn't do the line. But that's what I got.
Alright, good job. 97?
Yeah.
This is what?
Hmm.
Can I have a cupcake?
No,
Why?
because they are my fourth period's cupcakes,
Why?
because they like me better than you.
It's good.
They brought them in for my birthday.
Well,
All right, so when you solve this, you should get x is greater than or equal to 9. And then you also have to do the radicand. And with the radicand, you get x is greater than or equal to 0. So when I look at those and I don't see a bunch of number lines, when I look at those on a number line, if I have greater than 9, or if I have greater than 0, where do they overlap?
9.
Only greater than or equal to 9. I didn't draw. I was supposed to color in my dots and I didn't do it. I'm doing it right now. But that's the only place where they overlap. So you really need to look at that number line to see where they overlap. Okay, let's look at the last one together. Question B, what are we going to do first? Divide by 4.
Yeah. And then.
So I get the cube root of x plus 1 less than 2.
Cube.
So why are we doing a cube?
because it's cute.
It's a cube root, so we take it to the third power. So I get square root of x plus 1 less than 8. Just kidding. I don't have square root anymore. I get x plus 1 less than 8. Subtract that 1, we get x less than 7. Now, with cube root, does it have to be a positive number under the radical? Or can you take the cube root of negative 27? So this one does not have a second step.
Oh, yeah.
Because it's cube root, you are done. This is the answer. Yay for cube root. So if it's odd root, you don't have to do that extra step. If it's even, you do. So if you don't have any questions on last night's assignment, you can grab your computer. If you do have questions, which the majority of you probably do, then I can answer those questions too. Yep, the assignment is on Big Ideas Online, 5-4, day 2.
Squaw.